Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating exploration of branchless UTF-8 encoding. It's all about squeezing every ounce of performance out of encoding Unicode characters, without those pesky branches. Exciting stuff?
Branchless UTF-8? Sounds intense. I'm guessing it's about avoiding conditional statements like "if" and "else" during the encoding process, right? Why would we even want to do that?
Precisely. Avoiding branches is a big deal for performance. Branches disrupt the processor's instruction pipeline, leading to performance hiccups. Think of it like a smooth highway suddenly hitting a traffic jam. You lose momentum. This article tackles the challenge of UTF-8 encoding, a complex process for representing Unicode characters, without these pipeline-busting branches.
So how do they pull off branchless UTF-8 encoding?
The core idea is ingenious. Instead of using "if" statements to determine the number of bytes needed based on the code point value, they cleverly use a lookup table and bit manipulation. They initially considered a massive 232-entry lookup table, which is a bit impractical. But then, Lorenz suggested a brilliant workaround.
A workaround? Spill the beans.
Instead of directly looking up the byte count, they use the number of leading zeros in the code point. This reduces the lookup table size to a much more manageable 33 entries. Then, they use additional bit manipulation to handle surrogate pairs and values outside the valid Unicode range. It's a beautiful dance of bits.
So they're essentially encoding the information about the length into the code point itself through bit manipulation, and then using a smaller lookup table to decode that information? Clever.
Exactly. And the best part? The initial attempt involved a "count leading zeros" intrinsic, which, surprisingly, still had a branch. But the author found a way to completely eliminate all branches using simple addition and bitwise operations. Amazing!
Wait, I thought the whole point was to avoid branches. If the initial implementation still had branches, how did they get rid of them completely?
Ah, good catch. The initial approach used a "count leading zeros" instruction. While often considered branchless, it can still have hidden branches in certain architectures or compiler optimizations. The final solution cleverly sidesteps this by using a series of comparisons and additions, effectively replacing the conditional logic with arithmetic operations. The compiler then optimizes this into completely branchless code.
So this branchless approach is all about efficiency, but is it actually faster in practice?
That's a great question. The author acknowledges that while branchless, this implementation might not be the most optimized. Other techniques, like using DFAs or SIMD instructions, could potentially outperform it. The main takeaway is the elegance and ingenuity of the branchless approach, demonstrating a clever solution to a complex problem.
It's like a coding puzzle solved with mathematical elegance. I love it. So what's the overall impact of this work?
It's a fascinating proof of concept. It showcases the power of bit manipulation and clever algorithms to achieve high performance by avoiding branches. While it might not replace existing optimized UTF-8 encoding libraries, it's a valuable contribution to the understanding of low-level optimization techniques and a testament to the creativity of programmers.
Definitely a cool piece of work. Thanks for breaking it down for us.
My pleasure. And that's it for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time with more exciting explorations in the world of technology. Goodbye.
Bye-bye.